Assalamualaikum warahmatullahi wabarakatuh. Halo guys. Let me introduce myself. My name is Muhammad Fadli and I'm from Antasari Banjarmasin, Tarbiyah and Keguruan Fakulty, Mathematics Education Major Class A. So, for this event, I will complete my final task from my lecture, Mr. Ahmad Wapanizami, MPD, for making this video. So, the title is Less Common Divisor, Greatest Common Divisor, Operation on whole number, and properties of operation. So, before starting explanation, let us read Basmalah. Okay, and don't forget to like, comment, and subscribe my channel. So, happy watching! Okay. First material, greatest common divisor. In mathematics, the greatest common divisor of two or more integers, which are not all zero, is the large positive integer that divides each of the integers for two integers x, y. The greatest common divisor of x and y is denoted. For example, the GCD of 8 and 12 is 4. That is GCD open bracket 8, 12 close bracket is 4. In the name greatest common divisor, the adjective greatest may be replaced by highest, and the word divisor may be replaced by factor so that other names includes greatest common divisor. Historically, other names for the same concept that include greatest common measure. For more details, you can see the example at next slide. Using prime factorization to find the GCD. Step 1. Using a factor tree. Using a factor tree. 3. Okay, using a factor tree. List all the possible factors for the given number. Step 2. Write the prime factorization and circle the common factors. Step 3. Multiple the common factors, and that will give the GCD. Okay, next. For example, what is the greatest common divisor of 18 and 84? So, we can use the factor 3. So, 18. So, 18 over 3 is 6, and 6 over 3 is 2. 84 over 7 is 12. 12 over 3 is 4. 4 over 2 is 2. So, 18 is 2 times 3 times 3 times 6. And 84 is 2 times 2 times 3 times 7. The GCD of 18 and 84 is 2 times 3 is 6. Next. Second material, least common divisor. The least common multiple, or LCM, is also referred to as the lowest common multiple and least common divisor. For two integers A and B denoted LCM, the LCM is the smallest positive integer that is evenly divisible by both A and B. For example, LCM open bracket 2 and 3 close bracket is 6, and LCM 6 10 in bracket is 30. Least common divisor with two numbers. Find the LCM of 4 and 6. Least multiple of both. The smallest number common to both lists is the LCM. Okay, next. Answer. Multiples of 4 is 4, 8, 12, 16, 20, and 24. Multiples of 6 is 6, 12, 18, and 24. The LCM of 4 and 6 is 12. Less common divisor with three numbers. Find the LCM of 3, 6, and 10. List multiples of both. The smallest number common to both lists is the LCM. Okay. Next. Answer. Multiples of 3 is 3, 6, 9, 12, 15, 18, 21, 24, and 30. And multiples of 6 is 6, 12, 18, 24, and 30. Multiples of 10 is 10, 20, and 30. The LCMs of the LCM the 3, 6, and 10 is 30. I'm so sorry. This wrong. So LCM for from 3, 8, and 10 is 30. Okay. Oh yeah. Next. Yeah. Operation, whole number, and properties of operation. Third material. Okay. So definition of whole numbers properties. The properties of whole numbers are based on arithmetic operations such as addition, subtraction, division, and multiplication. Two whole numbers, if added or multiplied, will give a whole number itself. Subtraction of two whole numbers may not result in whole number, i.e., it can be an integer too. Also, division of two whole numbers result in getting a fraction in some case. Now, let us see some more properties here. Can whole numbers be negative? No, the whole numbers cannot be negative. The whole number starts from 0, 1, 2, 3, 4, 5, 6, 7 till positive infinity are whole numbers. All the natural numbers are considered as whole numbers. But all the whole numbers are not natural numbers. So the negative numbers are not considered as whole numbers. Definition of whole numbers properties. Next, what are the properties of whole numbers? The properties of whole numbers are: whole numbers are closed under addition and multiplication. The addition and multiplication of whole numbers is commutative. Next, the addition and multiplication of whole numbers is associative, obeys the distributive property of multiplication over addition. The additive identity of whole numbers is 0. The multiplicative identity of whole numbers. Next, the four properties of whole numbers are as follows. First, closure property. second, associative property, third, commutative property, and fourth, distributive property. Next, first, closure property. Add any two whole numbers and you will see that the sum is again a whole number. For example, 0 plus 2 is 2. Here, 2 is a whole number. In the same way, multiply any two whole numbers and you will see that the product is again a whole number. For example, 3 times 5 is 15. Here, 15 is a whole number. Thus, the set of whole numbers W is closed under addition and multiplication. That the closure property of W is stated as follows. For all A, B, set W. Second, associative property. The sum and the product of any three whole numbers remain the same through the grouping of numbers is changed. Example 1, open bracket 1 plus 2 close bracket plus 3 is 1 plus open bracket 2 plus 3 close bracket, because open bracket 1 plus 2 close bracket plus 3 is 3 plus 3 is 6, and 1 plus open bracket 2 plus 3 close bracket is 1 plus 5 is 6. Example 2, 1 times 2 in brackets times 3 is 1 times open bracket 2 times 3 close bracket, because open bracket 1 times 2 close bracket times 3 is 2 times 3 is 6. 1 times 2 times 3 in brackets is 1 times 6 is 6. Thus, the set of whole numbers with associative under addition and multiplication, the associative property of W is stated as follows. For all A, B, C, sets W. Next, commutative property. The sum and the product of two whole numbers remain the same even after interchanging the order of the numbers. Example 1, 2 plus 3 is 3 plus 2, because 2 plus 3 is 5 and 3 plus 2 is 5. Example 2, 2 times 3 is 3 times 2, because 2 times 3 is 6 and 3 times 2 is 6. Thus, the set of whole numbers W is commutative under addition and multiplication. The commutative property is the commutative property of W is stated as follows. For all A, B, sets W. And fourth, distributive property. The distributive property of multiplication over addition is A times open bracket B plus C close bracket is A times B plus A times C. Example 1, 3 times open bracket 2 plus 5 close bracket is 3 times 2 plus 3 times 5, because 3 times open bracket 2 plus 5 close bracket is 3 times 7 is 21, and 3 times 2 plus 3 times 5 is 6 times 15 is 21. The distributive property of multiplication over subtraction is A times open bracket B minus C close bracket is A times B minus A times C. The example 2, 3 times open bracket 2 minus 5 close bracket is 3 times times 2 minus 3 times 5, because 3 times open bracket 2 minus 5 close bracket is 3 times minus 3 is minus 9, and 3 times 2 minus 3 times 5 is 6 minus 15 is minus 9 or negative 9. So that's okay, so that's all my explanation. If I have wrong and deficiencies from this video, I am so sorry, and see you. Bye. Assalamualaikum warahmatullahi wabarakatuh.